Welcome to another Python tutorial video. In this video, I'm going to show you how to use the argparse model to pass arguments from the terminal or the command line into your Python program. But before I start, I just want to remind you to subscribe to this channel if you have not done so. I would really appreciate if you do that. Every week I'll be giving out new tutorial videos, and in the future I also plan to do videos about machine learning and AI. So it will really be encouraging for you to subscribe to this channel, and it will also help the channel to grow. And if you like the content in the video, please like and share with your friends or share with someone you know who needs the content of this video. So let's go into it. So the purpose of this video is to show you how to use the argparse model to pass arguments from the terminal into your program. So an argument is a value that is passed between programs, subroutines, or functions. They are independent items or variables that contain data or codes. The argument is used to customize a program to the way that we want the user to interact with the program. Here I have a Python script that processes an image, and in this Python script there's not so much that is happening. I'm using a package called OpenCV, if you know, for image processing. And what I've done here is just to import OpenCV and the sys model and NumPy model. And I have an image called Starry Night in the same directory as this Python script. So I put the name here so that OpenCV can read this image like this. And if OpenCV cannot see the image, then it exits. This is what this line means. So in case we cannot read the image. And then the processing that we have here right now is using a gray image, just converting the image into a gray image. So this is the argument that we use, or the OpenCV parameter that is used to convert the image into gray image. And this is the function of OpenCV that we use to do that. And in this line, we're just trying to show the image. And this line, we pause the image display until we press a key. And there's an option here. If we press S, then the image can save into a new name. So this program does what it's meant to do, and it's a very simple program. So I'm going to try and run the program right now. Yeah, so here you can see that the original image, if I can find it, I'll just go straight and open the original image here. So you can see the original image, Starry Night, and we have been able to convert the image into grayscale. So using the argparse model, I want to be able to extend the functionalities of this program. In essence, I want to be able to use this program to open any kind of image or any image in the path or in my computer and perform the same function on the image. If I want to do it this way, it means I have to always change this variable here, but that is cumbersome because I always have to edit the program, and that is prone to error. So I want to do it in a way that I don't have to edit the program every time, and that is where the argparse model comes in. So in this case, I can always write my program in a way that I don't have to edit this Python file all the time. I need to use it for a different image. I also want to add more operations, multiple operations. I want to be able to flip the image. I want to be able to do some other things, maybe brighten the image or darken the image. And so I want to have the option to choose between the operations I perform on the image. And finally, since there are different operations, we don't want to use the same name to save the image all the time. So I want the user to also be able to choose the name that is used to save the image. So to do that, the first thing I'll do is import argparse. That means now we can use the argparse module. Then we will create the argparse the parser object. So we'll say argparse dot argument parser. So what we need to do next, after we have created an object of the argument parser, is to add the arguments that we want to use in the program. So I can say parser dot add argument. The options that you have to use in argument parser is what is the identifier for the arguments that you want to use. So in this case, I want to use I for input. So this is a short form of the identifier, and I can also indicate a long form and call it image path. Then next I can specify the type of the argument. In this case, it's going to be a string, and I can also define if I want it to be required. So if the user doesn't supply this argument, then the program will not run. So I say required equals to true. Then I can provide an help message to let the user know how to use these arguments. So I'll say specify the path to the image. Okay, so that is the end for this argument. We have added an argument to receive the image path. Then I'm going to add another argument for operation. So in this case, let me call this the short form. Let's call this O, or for the long form we'll call it operations, or operation. In this case, let's call it operation. And type, let's call it a string. I mean, no, not string, integer. We want to use an integer type. Then is this going to be required? Yes, we want it to be required. True. Now the default for the required is false. So if we do not specify it, then it means that it's going to be false. Then let's print and help specify the operation. So for operations, which we can say 1 or 2 or 3 or 4 or 5. So I wanted to provide up to like 5 operations to use. So that is it for the second argument. For the third argument, I want to add the output name, the saving name. So I will say the same way. In this case, I'll say S for short name. I didn't put a comma there. So for the long name, I'll say save as. The type, let's make it string. We can use bool, we can use float, but in this case, this works for us. So required, actually, we don't need to require this because I want to have a default. So in this case, default is if the user doesn't provide a name, doesn't specify this argument, we will use this default output image dot jpg. My output is not correct. Okay, so let's also have help here. Specify the image output path. Okay, maybe we should add default. Default is output image dot jpg. Okay, now that we are satisfied with this argument, we have to show that, okay, now we want to use the argument. So we say arguments equal to parser. Show that we have finished parsing, parse args, and do this to indicate end of parsing. Okay, so now we can use arguments in the program. So let's try this. I will change this to arguments dot. So what is the name that we chose? Image path. So we say image path. So instead of choosing hard coded name, we can now use this image path to represent the input name. And for our output name, we can say arguments dot save as, and that does it for input and output. Now let us decide what kind of operations that we want to use. So here we have a gray image. Okay, we can keep this for now because we might need it. And we also want to add, so let's just add it here. We want to have gray image. We want to have flip left to right. We want to have edge image. Oh, that's not correct. And we want to have brightened image, and we want to have darkened image. Okay, so now I'm gonna have a control structure to choose between this. So I would say that if argument dot operation equal to 1, then it should be gray image. So what I would just do here is to just choose a new name, processed image equal to gray image. Okay, so in case of argument dot operation equal to 2, then it should be flipped image. So how do we do flipped image? So we say processed image equal to numpy dot flip lr image. Then else if argument dot operation equal to 3, then we want to use edge image. So we say processed image equal to cv2 dot canny. Okay, and for brightened image, actually to do a brightened image we need a variable to add or subtract from our image. So we say pixel change equal to numpy.ones. So ones are like an array that is all 1. So we have to specify the shape of the ones, then the data type equal to numpy dot onside int 8. In this case they are all 1, so we multiply by 100. So what we want to do is, depending on whether the user chooses a bright image, we add 100 to all the a value of 100 to all the pixels in the image. And if the user chooses a dark image, then we subtract the value of 100 from each of the pixels of the image. So we will say elif argument dot operation equal to 4, then processed image equal to plus pixel change. That is if it's brightened, right? Or we can do this should work actually. So arguments dot operation 5 processed image equals to image minus a pixel change. So now that we have written our program, let's see how it works. Before we run this way, now we cannot run this way anymore. We have to specify the argument. So let's run this way first and see what happens. You see the program does run and it shows us that the usage is this. You have to specify the image path. Actually, there's a default argument which is h, which is for help. We have to specify image path, and we have to specify the operation, and optional we have to specify save as. So first let's try for the help. That is one advantage of using the argparse, because it automatically generates an help message for you. So it shows you how. So in this case, if another person is using this program, then they can know how to use it. I see here that actually our operation is not really well defined. So before I run the program finally, I'm gonna try to make it more explicit. So I'll say 1 equal to, what did we use for 1? Gray, and 2 equal to flip, and 3 equal to canny or edge, and 4 equal to brighten, and 5 is darken. Okay, let's see that again in our help. So we can see, so now this is more helpful for the user. So now let's try to run this. So input is starry night.jpg, and our operation, let's make it 1 in this case, and we run. So you can see it chooses it uses the starry night, the image, then it chooses operation 1. Then let's quit this. Let's try operation 2 in case it's operation 2. Oh, it's not working. Operation 3. Okay, so let me fix this. So we need to specify threshold for canny. Threshold 1, threshold 2, 200, and that is it for canny. Okay, so let's try this again. Somehow we have not changed here, so we change here to processed image. Good. Now let's see. Now output of 2. See, it's flipped left to right. And output of 3 is our edge image. Output of 4, it's a brightened image. And output of 5, and a darkened image. This is not exactly what I want, so let me change this into add and subtract. So cv2.add image subtract. Okay, so this should work. Oh yeah, that's it. And one more try. Let us try to save with a different name. So bright.jpg. Okay, and we save it. So let's go here. You can see it has been saved as bright.jpg. So you can see this is a very simple and useful introduction to the argparse module. I'm sure that with what you've seen in this video, you can customize in different ways. You can use this to customize your program in different ways. It's possible also to specify the threshold for our canny image here, whether we want some kind of threshold. So there's so many things you can do with this, and I hope that you find this video useful. Remember, if you find it useful, like, share, and subscribe. See you in the next one.